What if I told you that scientists built something that moves forever, without using any energy? Not a machine, not a trick, a brand new form of matter that seems to laugh in the face of the laws of physics. It's called a time crystal. And somehow, it's real. To understand what makes a time crystal mind bending, we first need to talk about ordinary crystals. You've seen them. Salt, snowflakes, quartz. What makes them crystals isn't how they look on the outside, it's what's happening on the inside. Their atoms lock into a perfectly repeating pattern, like microscopic Lego bricks snapping into the same grid over and over, in every direction. Scientists call this symmetry in space. The structure is the same no matter where you look inside it. Now here's where it gets strange. A time crystal does something no ordinary crystal can do. Its atoms don't just arrange themselves in a repeating pattern in space. They also repeat their behavior in time. Imagine a group of dancers who never stop. They spin, clap, turn, the same sequence on loop, endlessly. No one is pushing them. No music is playing. They just keep going. That's essentially what's happening inside a time crystal. The atoms cycle through states in a fixed rhythm. Tick, tick, tock, like a clock that never needs winding. Physicists call this breaking time translation symmetry, which is a complicated way of saying this thing behaves differently at different moments in time, in a perfectly ordered way forever. Here's why this drove scientists crazy. There's a rule in physics, one of the most unbreakable rules we know, called the second law of thermodynamics. In plain language, everything in the universe naturally moves toward chaos. Your coffee goes cold, ice melts, stars burn out. Nothing maintains perfect order on its own. Nothing moves forever without losing energy. So when time crystals appeared to do exactly that, cycle endlessly, losing nothing, physicists panicked a little. Were these things breaking physics? The short answer, not quite. Time crystals need an external push to get going, a laser pulse or a magnetic field. But once that rhythm is set, they maintain it without absorbing more energy. They're not a free energy machine, but they're still deeply, weirdly unusual. The idea of a time crystal was first proposed in 2012 by Nobel Prize-winning physicist Frank Wilczek. Most of his colleagues thought it was impossible. The universe, as usual, disagreed. In 2016, a team at the University of Maryland built the first one. Here's how. They took a chain of ions, charged atoms, and cooled them down to near absolute zero, the coldest temperature that can exist. At that point, atoms normally freeze completely. But instead of stopping, these atoms were nudged with precisely timed laser pulses. The lasers gave them a beat. And then something remarkable happened. The atoms started flipping back and forth in a rhythm that was twice as slow as the laser driving them. They weren't copying the beat. They were doing their own thing in a locked, repeating loop. A time crystal was born. There was a catch. These early time crystals were fragile. Leave them alone for a few minutes, and they'd dissolve back into ordinary matter, their perfect rhythm collapsing into chaos. Useful, not yet. Fascinating, absolutely. Then in 2021, Google stepped in. Using their quantum computer. One of the most powerful ever built. Researchers collaborated with universities around the world to create a time crystal that was bigger, more stable, and far more controllable than anything before it. This was a turning point, because suddenly, time crystals weren't just a curiosity, they were a potential tool. Quantum computers are incredibly powerful, but they have a massive weakness. They're almost impossibly hard to keep stable. Information stored at the quantum level gets scrambled almost instantly by the slightest interference. Time crystals, with their locked, repeating behavior, might offer a way to protect quantum information, keeping it stable long enough to actually be useful. We're still in the early days. No one has built a quantum computer powered by time crystals yet. No one fully understands every quirk of how they behave. But think about what we've done. We've discovered a new phase of matter, as different from a solid or liquid as a solid is from a gas, that exists in time as much as it exists in space. It's not a gem. It doesn't sparkle. It lives inside quantum computers and physics labs, invisible to the naked eye. But it may be one of the most important things humans have ever made. The universe has been keeping secrets for 13 billion years. Time crystals are proof that we're only just beginning to find them. And the best part, the scientists who built them still don't entirely understand what they've created. Neither do we. And honestly, that's the most exciting place to be.